Hello friends, welcome to the video tutorial of C programming, and in this video we are going to study recursive function. Now let us see what is recursion first. The process in which function call itself is called recursion and the corresponding function is called as recursive function. Means what? Basically whatever function we have studied till now, what we do? We call that function from our main function, or generally function is called from another function. But in case of recursion, function call itself. Okay, so let us say it's this process. See, look at here. First call is initiated from the main program. Okay, means first time the function is called by the main, and then after, look at this statement. Here function is calling itself again. Function is calling itself again. So this particular function is called as what? Recursive function. So definitely this call should terminate somewhere, because if you are just calling that function, it will goes in infinite state and your program never terminates. Okay, so for that we have to specify the base case. We have to specify the base case. So base case, whenever base case executes or whenever base case evaluates to true, our recursive function execution will terminate. So whenever you are going to write a recursive function, your base case should be defined properly. Otherwise it will goes in infinite state. Okay, now where recursive functions are helpful. Okay, to solve the complicated programs, recursive functions are helpful. For example, a program of Tower of Hanoi. Okay, as well as some programs or some functions that are required in tree traversal. As well as in graph traversal. So actually all these are terms related to data structure. Okay, so this, whenever you are going to write this program without recursion function, your program become complicated. Okay, and you have to write too much lengthy code. But if you are going to write this program using recursive function, it will be very elegant, simple and less complex. But definitely you should have an logic, or you should have an ability to define it in the form of recursive function. Okay, so the basic logic behind recursion is that you have to divide your problem into small problems. Okay, basic idea behind your recursion is what? You have to divide your big problem into small problems, and then after solve that small problems and then combine the solution. That is the basic idea behind recursive function or recursion. Because what happens if we divide our program in small problems, then it is definitely easy to solve. Okay, and the base case actually defines the solution for your small problem. Okay, base case define solution. Okay, here I'll say base case defines solution for small problem. Okay, means generally we know the solution of small problem, and using that small problem solution we find the solution of our bigger problem. Okay, now in recursion basically one memory data structure is used, and it is called as stack. It is called as stack. Now why stack is required, we'll see that part, but before that we will cover one simple example. Okay, now we will see how to calculate a factorial of number using recursion. We actually saw this program using loop. Okay, now let us see how to calculate the factorial of number first. So in mathematics it is written in this form, means this is a notation of factorial. Exclamation mark is a notation of factorial. And how it is calculated? So 5 into 4 into 3 into 2 into 1. So you have to start from that number, decrease it by 1, and I take a multiplication of all these values, okay, and you will decrease it till 1. Okay, now according to the basic idea behind recursion, that is to divide your problem in a smaller problem and then try to solve your bigger problem. Okay, so let us write this in the form of recursion. See, suppose I want to calculate the factorial of 5. What will I say? 5 into 4 factorial. Okay, that means if I know the factorial of 4, what will I do? I'll multiply it with 5 and I'll get a factorial of 5. But again, I don't know the factorial of 4. So what will I say? 5 into 4 into factorial of 3. If again I don't know the factorial of 3, what will I say? 5 into 4 into 3 into 2 factorial. Okay, again I don't know the factorial of 2. So what will I do now? 5 into 4 into 3 into 2 into 1 factorial. Now I know the factorial of 1. Okay, so what is the factorial of 1? Factorial of 1 is 1. Okay, so this is your base case. This is your base case. Base case is what? Which you define for your smaller problem, or you can say it is solution to your smaller problem. So what we are doing here, we are checking whether my number is 1 or not. If it is 1, then definitely my answer is 1. If it is not 1, what I am doing? I am considering the current value of my number, okay, as here, I am considering the current value of my number and multiplying it by the factorial of another number, and that number will be reduced by 1. Okay, so I followed this process till my number becomes what? 1. Okay, so let us try to write it in C programming. Okay, so here I am going to return integer type of value. Let us call our function as fact. It is accepting one argument, say integer n. Okay, now always remember, first of all you have to define your base case. So what is our base case? If my number is 1, then my answer is 1. Okay, now there might be a case that somebody enter the value of n as 0. If initially somebody give the value of n as 0, at that time also my answer should be what? 1. So what will I say? If n is less than or equal to 1. Okay, means if my number is 0 or 1, what is my answer? Return 1. Return 1. And if it is more than 1 or if it is greater than 1, what I am doing? I am considering the current value of it. Look at here. What is the current value of it? It is in variable n. Then I am again using factorial term. So in my program, I am defining it using fact word or fact function. So what will I say? Fact of n minus 1. Every time whenever I am defining it, I am reducing its value by 1. Okay, now I have to collect this result somewhere. Let us collect it in variable f, and you have to declare this variable f in this case. Now no need to initialize it, because you are not saying that f is equal to f into something. You are directly assigning the value of f, assigning the value to f. So there is no necessity. And where is your final answer? Your final answer is in f. So you have to return the value of f. Okay. Now see, let us trace this program. Okay. Now here, let me erase this first. So we will get some space here. Now time being, what will I do? I will consider a factorial of 3. Factorial of 3. Okay, now it will come here. First call is given by the main function. The current value of n is what? 3. Now it will come here. Is n less than or equal to 1? No. So what is the current value of n? Current value of n is 3. What is the next statement? 3 into factorial of what? 2. Current value of n is what? 3. 3 minus 1 is what? 2. Again it will switch here. Again it will switch here at the beginning of a function. Now what is the new value of n? New value of n is what? 2. Okay, it will come here. Is 2 less than or equal to 1? No, it is still greater. Now it will come here. The current value of n is now 2. So 2 into factorial of what? 1. Okay, actually I am writing something wrong. This is your function call. So I should draw this line in this direction. This is your function call, right? So where we are, the current value of n was 2. So 2 will be considered into fact of 2 minus 1, which is what? 1. Now again call is given here. Again function is called. It will goes at the beginning of a function. So what is the new value of n? The new value of n is now 1. So is it less than or equal to 1? Yes, it is equal to 1. So what is the answer? Answer is 1. So the answer of this function call is what? 1. Okay. Now remember one thing. Actually there are 3 calls pending. Okay. So when you say return, that value will be written to the latest call. So which is the latest call? This is our latest call. And it is nothing but an answer of this call. So what is the answer of fact of 1? Which is 2. At that time value of n was 2. So multiplication will be done. 2 into 1 is equal to what? 2. And then this value of f will be returned, which is nothing but an answer of this call. So what is the answer of this call? 2. Now this call returns the value to its previous call. Remember this thing. And this is the answer of this call. Now what is the value of n at that time? 3. So 3 into 2, which is nothing but a 6, which will be collected in your f variable and will be returned. And again it will be returned to your previous call, which is this one. So the answer of this call is 6. Now this is the initiating call. All the calls are what? Finished. Okay. And we got our answer. If you check the factorial of 3, look at it, 3 into 2 into 1. What is the answer? 6. Okay. So we got a correct answer, right? So our program is what? Right. So remember this thing, that whenever you say return, that return statement do not return to your main program. It always return to its latest calling program. So here the first latest call is this, then after this, and then after this is the last call. Now as I told you, a stack structure or a stack in memory is used in recursion. Now where this stack is used? Basically this stack holds this function call. This stack holds this function call, and whenever we start returning the value, all the values or all the calls are traced or back traced, you can say. Okay, so basically this stack memory structure is required to hold all the consecutive calls that we have given during the recursion process. Okay, definitely recursion process is very costly process because you have to maintain this much calls. If you compare this logic with a loop, in loop what we do? We just use one single variable, that is f. This is our statement generally, f is equal to f into n, and then we decrease the value of n by 1, and we did this process till my n is greater than or equal to 1. That's it. So only 2 variables are required. Okay, that will be mainly of type integer or long integer, but here your computer has to backtrace it also, it has to put the data in stack, and whenever we say return, it has to bring out or pop out the data from the stack. And again, as many calls are there during the recursion process, it has to hold that calls also. Okay, but still your logic is what, or your code, if you see the code complexity, it is totally reduced. You hardly completed this program in 4 to 5 lines. Okay, but if we write the same program without recursion, see, this is actually the simple example of recursion. So definitely you can solve it using the while loops, and definitely you will think that it is quite easy with the while loop than that of recursion, right? Okay, but there are some cases, if we write it without recursion, we have to write lots of code, and that code is very complex as well as lengthy. Okay, I gave you example also, Tower of Hanoi or the tree traverser program, graph traverser program. You cannot imagine that program without recursion. Okay, so since it is costly, sometimes it also reduce the complexity of a program, and as well as it is easy to code. Okay, that's why recursion is used. Otherwise, wherever possible, definitely you can go for loop, because as you can see here how it is working exactly like a loop. Okay, see here, our loop will execute till my value of n is greater than 1. Here also this function recursion process will continue till the value of n is what, greater than 1. Okay, so always remember, while writing a recursion function, you have to define the base case. If you do not define the base case properly, your program goes in infinite state. Okay, so let us execute this program in code block. So as you can see here, I already wrote a program name as recursive factorial. Okay, prototype is defined. A function is defined where function call is given. Look at here, this is the function call. Remember this thing, whenever you are writing a recursive function, there should be a function call to itself, to the same function. Otherwise it will not considered as a recursive function. And first call is initiated from main. Means first of all, main function will give call to it, and then after that function will call itself. And as I told you, once it start returning a call, once it start returning the value, then after it will return to your main program. So let us execute this. Let us try for 3. Yes, it is working. Let us try for 5. Yes, 120. Okay, you can try for the bigger values, but actually in that case we have to change our data type. Actually here I considered integer data type only. So you can define long int data type and check for the bigger value also. Okay, so I hope you understand the concept and idea behind recursion, and as well as how we define the recursive function. In next video we are going to see one more example of it. Okay, if you have any doubts or any questions, you can definitely write it into the comment section. I will definitely try to solve it. Thank you so much.